Welcome to the Databricks Skill Builder series. We're glad you're here.
So I will go ahead and get started. Today's course, we're going to cover an introduction to data science, and more specifically, data science on Databricks. And so I'm a solutions architect with Databricks. Prior to Databricks, I was a data scientist in automotive aftermarket, focused on marketing. And before that, I did a lot of data integration work. So as I like to say, I was a data janitor, so MDM implementations, a lot of data quality pipelines. So having been on the data prep side and the data science side, I'm excited to present this to you today. A little bit of housekeeping. We do have some great other essays on the phone helping run Q&A. This training is being recorded, so you're going to have it afterwards to follow up on. I'm going to paste a link to the notebook that we're going to go through in the chat, so we can you can follow it along. If not now, you can do it later on. So let me just drop that in there. Here we go. Because that question always comes up: is it being recorded or is there a notebook? So hopefully that's covered. And as for the chat, you know, the folks are going to do their best effort in answering, but if it gets a little too deep, there are some conversations that don't really lend themselves for Q&A, so we might just suggest you follow up after the call. So with that, let's get into it. I'm sure you've heard all of us talk about the Data and AI Summit. We have an in-person and virtual option. I would suggest registering, and you can just watch the videos asynchronously after the summit, because everybody's got a lot of stuff to do during the day, but we have some really great speakers, great training too. So especially on the data science realm, you can jump in and see the topics of interest to you. And there's no cost to register. All right, so as for the agenda today, we're going to do an overview, talk a little bit about the data science ML lifecycle, and then we'll jump right into a demo. So for an overview, who we are, Databricks, we're the data and AI company. We're focused on helping companies get value from their data. We're proud to be a leader for the both database and data science quadrant. And really what that means to you is, if you think of your data science as a full pipeline, we're one place that you can do it all. And our founders created some of the best of breed open source tech like Spark, Apache Spark. Recently, the Delta Lake and ML Flow for ML Ops. So transparency and open source is pretty core to our company. And buzzwords aside, we probably sound a lot like a lot of other companies in the space from a marketing standpoint who talk about big data, data lakes, and clouds and AI. The difference and where we really separate ourselves, it's the results from our customers that separate us. So with over 5,000 and growing, 450 partners and thousands of people trained on Spark and Databricks, this is where you're starting to recognize what we do versus what others are trying to accomplish. So we work with all three clouds. So if you use Azure, AWS, or Google, they're actually investors in Databricks. So wherever you are doing stuff on the cloud, we can help. So let's talk about the tech maturity curve, or the data maturity curve. On the left side, it's really looking backwards. So this is your domain of the data warehouses and where we've been for decades. The innovators are over on the right-hand side today, and that's using data to predict the future and looking at how you or your customers will behave, or how the environment is behaving and reacting to in real time. So the challenge that most companies are having is they implement two different platforms to answer their questions: data warehouses for BI and data lakes for AI and machine learning. And the platforms are incompatible with each other. Generally, you need data from both systems to deliver really game-changing outcomes. And that makes success with AI tricky. So with the Databricks Lakehouse platform, you have all of your data, structured, unstructured, in one place. The data actually resides in your cloud bucket, but we bring reliability and really fast query performance to the data without it ever leaving your data lake, using a technology, an open technology called Delta Lake. And you can use it for your data warehousing loads and for your data science alike. So this is kind of a simplified data architecture, and we'll go through what that actually looks like, and not just in a diagram when we jump into the demo. So one platform means you have a lot of freedom to evolve your data strategy. And with us being open source, you're not locked in or walled into a certain technology, and you can use the tools you're familiar with. So let's talk a little bit. That's enough of the overview, but let's dig into data science and machine learning. So what we have found is there's a lot involved in data science, from data all the way to deployment. And code is actually a really small portion of that. So if you look at it, there's really three categories that can be problems in any data science program. First, data itself is a huge challenge to machine learning and AI. Most enterprise data resides in silos. So this is on-prem databases, multiple clouds, maybe zones or lakes. And feeding it to ETL systems to make it ready for machine learning can be difficult. I know from my past experiences, a lot of times we would have copies of data, and so as to not affect the BI workloads, we do extractions and work off of that, which means at some point your data is out of sync, or you're going to have copies. And you can also have challenges accessing data with negotiating governance and policies. And, to some extent, data can be difficult to process. There's lots of formats data comes in these days. And a lot of times it can be stale if you have copies of it, for example, by the time it reaches, data scientists or engineers. Second, low team productivity when it comes to machine learning. So having your team work with retrofitting existing legacy systems and tools, lots of legacy hardwares that we have in our enterprises. And it can be challenging to have a standardized way for domain experts and data scientists to engage with each other. So what that can look like is, copying models over to a share, or, actually even working in different systems altogether. And lack of collaboration can lead to project delays, and the interactivity of thinking, if you're doing a single development on a machine, or people are working separately, you have to hope that they're checking in their changes in a Git repo or something. So that can lead to just complications in that deployment process. And so even if you have 1 and 2 settled and you have a great data science practice, productionalizing it in the real world is difficult. It can be very difficult to productionize processes, machine learning workflows, due to non-standard processes, siloed processes, ad hoc tools, even having to coordinate so many different people in their different tool sets to do model deployment. So the lack of a platform approach leads to really rough handoffs, and the machine learning life cycle becomes cumbersome and slows down innovation. I know when I've been in a place like this, it's taken us like 6 weeks to deploy a model. And, of that, the actual development of the model was pretty quick. The longer tail of that was negotiating security policies and getting the model into the right hands. So let's talk about how to solve these problems. Like first, let me just do the build. First, for data, the challenge of data sprawl, having the data in the same data native platform. So you have a platform that allows for that discovery, access, reuse of data, and reuse of processes. So not having to build everything just bespoke every time you're doing a model. Seamless access to the most recent data using tools that your team is familiar with. Next is speed, especially if you're talking about machine learning at scale, enterprise scale. So to make machine learning projects more collaborative, make sure your folks can use the tools and languages and infrastructure of their choice, have the teams work together and have one place to share and collaborate, and in a performant way. So being able to do your work in a distributed way. A lot of the data sets can exceed, what you can reasonably do on a machine. So this is where Spark and distributed computing come in handy. And then having scalable components for the entire machine learning life cycle. There's lots of ways you can track models, and you can track model versions. But to some extent, there's a lot of processes that require some somebody to remember to do something. So having things automated kind of takes that human element out of it. Also, just thinking in recent years, there's been a lot of job turnover and people moving in different places in and out of orgs. There's a lot of tribal knowledge that's relied upon as far as how to, why a model does a certain way, or why you deploy it in a certain way. So having something that's like enterprise grade and just ridiculously easy to use is pretty important, especially for handoffs and deployment. So let me do the build. So again, I'm not going to belabor the point, but the Delta Lake platform that you're going to have in Databricks, it handles a few of the things. Number one, it can handle any of the data formats that you want to do machine learning and data science on. And it's really no different. You can, treat all of these very similar. You can run your models using, do your data prep doing SQL, doing Python. And it's the difference between consuming things as stream and batch is actually quite small. It's one paradigm to score batch and streaming data. And you can simplify and isolate your data set version. So, one thing that can happen after developing a model is you go back and, try to understand what the data looks like at the time that you did the modeling to be able to have that transparency of the data, which you have with features like time travel that are baked into the Databricks platform at Delta Lake. And so you can go back in time and see why a model made the choices it did. And then you need, ML specific tools for data and features. So, and you want the tools, you don't want to have to learn a whole new tool set. So be similar to the ones used by your data engineering team and the rest of your data systems. So if you don't have that in one place, you end up having to manage multiple systems. And that's where a lot of productivity is lost and complexity is introduced into the process. So let's get into more fun parts. Let's talk about building data science, machine learning workflows. And first, we're going to start with, once we jump into the demo, you'll see the workspace that you do your work. It's very similar to a Jupyter notebook. One thing is, generally when you're starting a data science project, you load your libraries, kind of first stop, you load sklearn. We have an optimized runtime that in Databricks for machine learning, and it includes all of those standard ML libraries that you would expect, sklearn. It has PyTorch tokenizers, TensorFlow, and even things like Hugging Face. And that can just save a little bit of time as far as loading things when you're needing to run your models. And it also speeds up your cluster creation. So you have, you make sure that all of your installed library versions are compatible. And, when you're using a modern runtime, and for Databricks, for me, I consider that like 9.1 and up, the tracking of the model runs is automatic. So we'll dig into that, what it looks like in the actual demo. And then you can also track when you have this automatic tracking, you've got the automatic tracking of your features that you can log the features and understand your measurement criteria, the parameters that were used, and easy ways to visualize it. So if you think about it, we're not really running one or two models anymore. We're running like hundreds and thousands of models at scale. So this is, we have a kind of baked in way to visualize and look at that as you're doing your model development process. And as we're talking about runtimes and libraries, let's also talk about compute. If it would be great if we had unlimited funds to throw at, our compute costs, but like literally we have to show a ROI on all of our work. So you have more and different levers with distributed data science to make your training more efficient. So gone are the days of the brute force parameter tuning. It's not effective. I mean, it is a problem that can be solved with computing, but there's options with kind of Bayesian optimization for finding optimal parameters. So you don't have to just go all across the feature space and hone in on what you're tuning towards. Parallel model training. So if there's one thing that you do after this call, look up pandas UDFs, and I can post a link in the chat. Actually, let me just do that. Do yourself a favor, look this up. It's open source technology, and it's going to save you some time, especially if you have to do the same model run across like multiple groups. The pandas UDFs can really save you some time. You can run the same model for different groups, segments, geographies. It's limited only by your imagination. Then also, once you're getting into deep learning, let's talk about parallel training. So you have some libraries that are actually optimized for and designed for parallelized distributed computing. So Spark ML, and then using things like Horovod Runner with TensorFlow and PyTorch. So these are preloaded on the machine learning runtimes, and just these are different techniques that you would use, versus doing a single machine type processing. Okay, here we go. And then I've talked about collaboration before. The data science workspace and the machine learning workspace really facilitates this collaboration. We support multi-language notebooks, so you can use Scala, or really Python, SQL, R, or Scala if you choose, all within the same notebook. So different languages do things better. Sometimes it can be easier to do your prep with SQL queries, and SQL for munging the data, and Python for doing some of your pandas formatting. So we have multi-language support, and it really comes together with your cross-team collaborations. All of the notebooks you can have, it's very similar to Google Docs or the new Word docs, where you can interactively help edit and comment. So that's really the way, especially with COVID and people working remotely, that's kind of how people are used to working together. And this extends it into the data science realm. And then, really importantly for machine learning, the workspace integrates tightly with MLflow. So engineers can track parameters, metrics, models, all in the context of specific experiments. So typically you have more than one data science, problem that you're solving at a time. So this has an easy way to organize this information. And it also works nicely with Git or any of your versioning that you use. So we're getting into MLOps a little deeper here with MLflow. MLflow is an open source software that we contribute to. So I'm going to put in the chat a link to the Databricks docs for MLflow, but also the open source docs for MLflow. And they are always looking for folks that want to contribute to the open source community. There we go. So jump back in here. All right, so let's talk about the different components in MLflow. An MLflow project, it's a format for packaging data science code in a reusable and reproducible way. Really, the best data science is reproducible data science. An MLflow projects component includes an API and command line tool for running projects, and that integrates with a tracking component, so you can automatically record the parameters and the git commits of your source code, again, for reproducibility. Next, we'll talk about models. And an MLflow model is a standard format for packaging machine learning models that can be used in a variety of downstream tools. So for example, batch inference using Apache Spark, real-time serving through an REST API. It allows you to manage and deploy models from a variety of ML libraries to any model serving platform or inference platform of your choice. MLflow tracking components lets you log and query machine learning model training sessions or runs using Python, R, Java, and REST APIs, and allows you to track experiments to record and compare parameters and results. So currently the MLflow tracking server, you track parameters, metrics, artifacts, metadata, and models. And we know that these models, they go through an elaborate life cycle before they can be deployed in production. So that gets us to model registry. And model registry allows users to collaboratively manage models across different users and groups, and have the right people weigh in on when a model gets moved into different stages. And you can also track production lineage and additional artifacts like launch reports. It's available as UI and again, a set of APIs. So you can manage the full life cycle of MLflow models, in the UI or with API or CLI calls. And something that's not going to be covered today in an intro to data science call, but just keep watch, especially in data and AI summits, they're going to cover this, model serving and model monitoring. Model monitoring, especially, that will knock your socks off. So keep an eye out for that. That could be a topic for a future session. That literally could be its own full hour session. Because, data science is not set it and forget it. So this is just a different view really of the life cycle and how it looks with the stages. So you have your using the libraries, the tools of your choice to do different flavors of models. You track all of these different components so you can compare, and sometimes the model with the best score isn't always the best model for some practical reasons. So you have a good way to easily compare. And then let's talk about model registry. You can have different versions in staging and production. You can archive versions when they're no longer serving your business purpose. And if you can A/B test models against each other. And then as far as serving, there's lots of different cloud serving solutions. So Docker, there's going to be some built-in model serving options. So end-to-end flow. So let's dig in a little bit. We've talked about the artifacts that are being captured. And this is just a little, before we jump into the demo, this is a bit more what it looks like. So you can see the batch sizes they're using, if there's any class weighting, what optimizer you're using. So you have a very quick way, simple way of capturing and viewing this information, different ways to visualize it. And you have these artifacts. So you have your models, you have a YAML that has information about how to reproduce the model, and even some validation CSV file. So again, all in the name of being able to make this reproducible. You can capture and explore your hyperparameters visually. And this is caught as part of the tracking process. And again, yeah, good data science is reproducible. So you can automate that capture of code, your cluster specifications. So you might not remember exactly the computing setup that it took. So this helps take that lift off of you to remember exactly what environment that you're doing your modeling from. And then model sharing. Model governance can be done through the UI or API. There's webhook integration. So depending on what your organization's workflow is, some companies will do this model governance through webhooks with Slack, so that you can Slack your teams to have somebody review and look at the results of a model before provisioning it to the next level. And that's all possible through this model registration. And then automated model lineage and governance. So this is where that tribal knowledge is kind of captured. So you can see what activities have happened, who transitioned it, or if somebody rejected it, why did they reject it? So you don't have to go searching through emails to find all of this information. You have it tracked within the tool. And so we're going to jump into the demo. Right. So I shared this link in the chat previously. This is the end-to-end example that we're going to run through. One thing, if you look through the actual document, it says where to navigate and grab these files from, and it assumes that you've already loaded this this file to your DBFS. And I'm just going to go ahead and give y'all do a favor. Here's some alternate code for that that'll actually just go out to that site, and you can download the code directly into your notebook. So boom, bonus. And this is what it looks like. So that code that I just pasted in there, instead of for your section, this might not run because you might not have this loaded to your DBFS. So you can just add it or comment that out and put in the code. This goes to uses pandas, pulls the URL in, and then reads it into a data frame. So I know this is being recorded, so we'll just leave that there for a second. Okay, so moving on. So the code came from this, the open data sets, and it does not have a designator. So we're going to create this new feature as red. And if it's red, we're going to be predicting if something is red or not. So we're going to change the value for this field to 1 if it's red and 0 if it's white. And we'll put the data frames, concatenate the data frames together. And then one thing that was unique about this data source that we, let's see if I can just run that real quick. I think my server's still alive. The data frame names had spaces in it, which, you know, that can cause problems in different systems. So we just did a real quick call to replace these spaces with underscores in place. So within like the current names. Next, you can visualize the data set with Seaborn, Matplotlib. So there's that way of visualizing data. There's also, if you're just looking at a data frame, there's also within the notebooks, you can do visualizations. And I realized with my, I was very eager just to jump into this, the notebook real quick. Let me take a step back. I apologize. And just look at the user interface for Databricks. So it's a web-based UI. We do everything in personas. So there's really 3 personas. This says data science and engineering. I really consider this more data engineering. You have slightly different options. This is the place you would go, you know, if you're only interested in doing, you know, data manipulation in your notebook, like cleaning up and featurizing, you might just work in this space. It has repos, which can connect to your Git provider of choice. You are able to see different recent documents. You can search. If you know that somebody worked on an interesting NLP project, you can search for, you know, what keyword search, looking for things within notebooks. So I can look at different NLP projects, for example. Data. So this is where the DBFS is can be connected to your cloud buckets, or when you're, after you load in the data, you can put it into tables. These are Delta tables, regular tables and Delta tables that you'll be hitting and you'll be creating through your process. Heart of a lot of things is compute. So if you have to create compute power to run through, you know, building things, it's pretty easy to create one. So let me just do create cluster and just look at a few of the options. You're going to name your cluster. There's 2 different modes mainly that you're going to use: standard and then single node. So if you're just doing development and, you know, just quick hit development on machine learning models, you might use your single mode. You pick a runtime. So since we're doing data science and machine learning, you always want to use an ML runtime. If you're not, if you're just, you know, manipulating data, you might use a standard runtime. In this case, we're going to use ML. The higher the number, the more optimized. So with every single release of these runtimes, we do things in the back end to optimize things, to make it run faster, to do things automatically, to abstract away some of the nitty gritty compute stuff, instead of you having to keep it all in your head. Back in the days, the early days of distributed computing using Hadoop, you had a whole bag of tricks of little shortcuts and ways that we would optimize things. You know, it's not completely abstracted away, but there's way fewer things to remember, especially in the platform. And then workflows. After your development's done, you can automate jobs to run, and you can automate pipelines of jobs to run. So, you know, if you have dependencies, run this job after that one. This is the kind of things you can schedule in a workflow. So what that might look like, this is a single node one because I just picked one out of the hat. But if I wanted to say after that job runs, that's a dependency, let me do this new task. And you can select a notebook, you can run a jar. So if you have if you're using some like Talend, I'll see people export Talend jars and you can schedule and run them. You can Delta Live tables is a whole different topic, or Python wheels. So anyways, this is the data science and engineering view. Where we are today, and we're going to focus and stay, is this machine learning. We're not going to cover it today, but there's AutoML embedded in here. And if we have time, I'll hit it. repos, this workspace is where you keep notebooks for development. Like I consider these my Scratch notebooks, but for projects that I'm working on with other folks, I will have it in repos so I can add and push my own changes. You're going to have that similar recent files because, rarely are we working on one project at a time. Same search functionality. This is the same data. So whether you're a data scientist or a data engineer, you're all hitting that same data. And it's the same compute. So the compute that I might have just created, I can use in this persona as well. And you also have the same concept of workflows. So from a data science perspective, you might have one notebook that does data prep, and then it might do one model. You might bifurcate it and have it run multiple models. It's really limited only by your imagination and orchestration. Experiments. So the experiment that I'm showing today is about a wine demo, but I can also have multiple experiments going on at any given time. Feature store, I think we'll touch on it, but feature store is kind of a newer offering, and I absolutely look at it. It's built in where you can reference and keep information about the features that contribute to your models and keep track of them. So I will just go ahead and dig in a little bit. You can see who, if you have a feature store table, these are the variables that you're going to use in your model. You can see how it was made. So I had this one notebook that created this one feature store for a different taxi model. But you can also see where it comes from and it goes to. So like, let's say if you have this one field that is being used downstream and you find that data was corrupted, you can actually kind of follow what the impact is and adjust the models or adjust the data. You have a better idea of the lineage. This one doesn't have, they're all similarly named. So that's, so you can see the notebooks, any jobs, if you have scheduled jobs that are using these would show up as well. Endpoints, so if this is being served up through an endpoint, again, it lets you have a little more control and visibility to where your features are and how they're being used. And then last, we'll look at this a little more as we step through the demo. You have your models that are a subset or a part of experiments. One experiment can have multiple models. I had mentioned my internet was not being awesome, and that is happening at the moment. So let me just jump back to my notebook because I know I have that loaded. So yes, so pardon that sidetrack, but I just realized I got very excited and just jumped in. So back to, we loaded data. We did a little bit of data prep, created that new field is red. So having seen that there's several of y'all are data scientists, I'm sure you're familiar with this data set. Visualizing data. So again, you can do data exploration using Seaborn or any of your data viz tools. This one shows that there's a different distribution for quality scores. That makes sense. We're going to define high quality as having quality of over 7. So now we've created this new feature, high quality, and we're going to add it to that to our data frame. We're going to do some box plots for visualization, very similar to what you might already be doing. And we have our data pre-processing. So we're going to look for missing values. And yeah, this is a very simplistic example just to go through kind of the overall process. In this case, we're going to use sklearn. And we're going to build our baseline model, which is here. We have an sklearn wrapper. One thing that I'll show is we're importing MLflow here. Even if you didn't, and I think I have a quick example. With a modern runtime, this gets tracked. So I know I showed you a little bit of this experiments tab here, but for this actual notebook, I can also get to the experiment by looking in the side panel. So here, I've run the experiment several times, so I can take a look and look at my best rate. And if I want to, I can just jump in and open up and double click into that experiment. Let me move my menu bar is blocking where I can't see it exactly. And we can jump into the experiments tab. Revision history. So I don't know if y'all have ever done this. I certainly have never accidentally made changes very late in the day and then realized the next morning that I just really did some bad things to my notebook and I need to get back into a better state. The revision history has all of the changes that I've done. So yes, you're not misreading that. I did do some changes at 1:14 a.m. So if I decided, let's keep it back to just the changes this morning, I can revert to different points in time. Comments. So we talked about being able to be interactive with it and do comments. You can add comments into the code and just say, hey, did you mean to load all this? And leave comments for each other. And then what it looks like, you can also tell if you have somebody else working with you. I'm just going to duplicate a tab to show it. You can also see if somebody else is in your notebook working with you. So you'll have different squares. It's going to come up in a second. There'll be an H here, and that means that, there's another person helping you with the notebook, which is pretty handy, and you can chat back and forth. It just makes that interactivity a lot better, and you can keep in sync as you're working through your modeling. So this is nothing fantastical about logging and creating this model. It's pretty run of the mill. What is cool is where you can see it was logged. It logged one run to an experiment, and then it's got a link to documentation. Feature importances. So as a sanity check, what are the feature importances that contributed to my model's decision? So I could see this is one of the things that is available through MLflow, and I look at the feature importance. As we saw in the box plots, alcohol and density are important for quality. Great. We logged, for this case, area under the curve. And I think also saw it when we looked at the experiments tab that it surfaced AUC as what we were training for. So registering the model in the model registry, this is we're just going to pull the run ID, and we're going to add this register the model. It does take a second, so we put in a little sleep here, but it's just a matter of running this so that we can register a model. So you don't always have to register every model because some are duds, but if we have one that's high performing, you can track it here. And I've just noticed that my little H showed up. So this is, you can have multiple people in. I've worked on it where we've had 3 of us working in and just tackling a different section. Obviously, you got to be careful about running when you've got a bunch of people in it, but it is a good way to get somebody else to click eyeballs on your code and work interactively. So we will see the model in the models page. This is just code to transition stuff into production and load the notebook from the model registry. So this is a okay. Sorry, for some reason my microphone changed. Okay, great. So this provisioning to production, and then we have a model path. So we have models wine quality production, and we can see the AUC score, which should also match the AUC from MLflow. So there's lots of different versions. This is the version from where we picked in production. I've run it a few times since. We can experiment with new models. So let's say that, this was great for a basic model, but what happens if you decide to add more? It just, spoiler alert, you run this and it adds on to your experiment runs. So you can, really run as many. We have customers that run tens of thousands when they're doing model training. So this can scale as much as you need it to. And then I think I've showed the hyperparameter. Let me jump into to actually look at the models off the model page. We looked at experiments, and I think models, we just got to get it to load. One thing I did want to mention, if anybody is using community, so if you're not a Databricks customer, that's fine. We have the community version where it's a little, it's a workspace where you can run these notebooks that you find. I will say that there's some limited functionality, or there's some functionality that is not available, and I'll just point those out in a second. And yes, I am a capstone advisor at SMU, so I was logging in with my SMU credentials. It doesn't have to be, work credentials for community. So the big thing is there's no model registry if you're dealing with your community edition. So as we go down in the notebook, there's going to be some things that won't work in community, and that's not an error. That's expected. So I'm going to keep moving down. It is absolutely the fact that I'm in a very small room at a WeWork, tethered off of my phone running this, that we're having performance things. We can update the production model. So let's say if I ran this and I did get a better score, I can provision this model to be the official production model. And, they say click models in the left sidebar to see that there's new versions. Let's see if models, yay, models came up. So I'm going to search for my wine model. And we'll give that a second to run. There we go. So actually, we'll just search by last modified. This is an environment that has lots of solutions architects that work and develop in it every day. So yeah, there's 2 of us working with wine quality at the moment. So we're going to dig into the model that we created with our workflow. And we can see that I have different archive versions. I have 66 versions. These are older ones as well. Model serving. So we'll let this pop up. This is some of the screens that we kind of looked at beforehand. I have models that are pending before they go into the right version. I have this turned on for model serving. So I can actually use a model for inference. We try to make this kind of easy for you. So if I want to check my production model, and I'm going to browse, I'm just going to find it's in my default table. And then I actually pulled in a model. Okay, wine update. So if I want to run my model against this new table, I can use the model for batch inference and send it to this folder. So we try to make it very easy for this. It will actually generate a notebook. We'll let that run. And this notebook I can schedule to run. So I didn't have to create any of this code. Just clicking that button created this notebook so that I could do my own inference. If I wanted to change where the data came from, I can just edit this notebook and say I want it to come from a different source. I'm going to actually hit the back button, go back because there's more stuff, more fun stuff on the models page that we're going to hit. So we're going to jump back to the serving tab. We can see the model event. So this is where you have that history. I can see the cluster settings. So like, what did it take? What size of a cluster did it take to run this model? And I can also, if I want to call the model through an API, I can have this automatically generates your curl code, or you can copy paste this Python code and use that to call it. You can have version events. Yeah. So a lot of it, in the spirit of transparency, a lot of this, like I didn't have to do a bunch of extra stuff to have this logged. It was auto created as I ran through that process. All right, I'm going to go back to my notebook. And then again, here's the batch inference code. I'm not going to run it again, but this was a lot of this stuff. You don't have to remember, how to code it. The code's generated. And then, yeah, we're going to create a Spark UDF so we can apply the model to a different table and we can get our predictions. Oh, wait, that's new data. Sorry to run it across. And then model serving, we looked at it a little bit. I don't have my token here, but this is, I copied that information from model serving. So this is the information I need to test it and run, and it even has kind of a fail exception catching. So I can do model predictions from an endpoint, and it should match anything that I do locally. So this is the natural end of the notebook. One thing I was going to, we have a few minutes, and let me check. Q&A looks good. Let me just jump into AutoML. So like I did a lot of hand coding for that, which is great. You know, we have a lot of existing code that we like, and we can import that into Databricks. It's just as easy as, you know, going to my workspace and saying, hey, let's import something. For example, this URL, if you were loading this yourself, copy that, import notebook by URL, and then boom, it loads up the notebook. So yes, you can absolutely code by hand. But if you want to just let the AutoML run for it, I'm going to use my cluster and do a classification problem, because this is a classification problem. I'm going to go to default, and then I will use my wine table, HH wines, and the code for creating that obviously is down in here. Lots of different ways to create a table. My prediction target is red, and then it gives an automatic experiment name. But if I want to call, you know, this is my best model, or my new one, or my Friday one, you can do your own name. There's a little bit of advanced config. It's defaulting here for F1 score. You can also decide, if I don't want to use light GBM, I can say, like, don't use that framework. I can set out my stopping conditions. So like, I don't want to do it for an hour for this training. If I have a time column for the split, I can designate it. And then this is the default storage location. So I'm going to set this to go for a minute. When this runs, there are three things that are created. And it's going to take a hot minute to do it, but it creates automatically an EDA notebook just to help you on your exploratory data analysis. It will create an AutoML notebook. It'll create a notebook for every one of the models, every one of the runs. So so if I do this 50 times, I'm going to have 50 notebooks automatically generated. And I might, I think again, I'm having gremlins from my bad internet situation here. So the experiment's running, even though I even got the error messages, it's just going to keep trucking. So in a minute, this is going to pop up with the data exploration notebook. I'm going to have like transparency to all of the notebooks that create the models. And if I want to, you know, judge them, if there's a model that was created that I don't like how they did the encoding, or I want to, I was just seeing if I had a recent one that I've looked at, I can edit it. So, you know, these are my notebooks. I can do whatever I want with them. I can change the encoding. I can adjust it as possible. You know exactly how the model was created for your model. So I'm going to let that do its thing for a bit. And let me think. So that is the end to end. Stephanie, or is there anything on in the chat that I need to answer? Or does anybody have questions while I have all that running? I'll try to keep an eye on Q&A for a second. The other thing I wanted to mention, and that, yeah, it's still live. I did a little off-roading this yesterday for like, what I was trying to think of, like, what is the easiest, like laziest way I could possibly do a data science notebook. And so this was my brilliant idea, you know, is like doing it in less than 10. So back in September, we acquired a company called we bought a company called Bamboo Lib. This is part of our new our runtime, that is runtime 11. This is in community edition, so I don't have full exact functionality, but I was still able to use the same data. That data that I copied in, the code that I copied into the chat, this is that same code. So I pulled, actually, let me just go ahead and start this cluster. I'm gonna have to create or start this that I did. I might have run out of memory. Okay, let me just, oh, you know what? I'll clone it because I already have it set how I want it. All right. Now I'm going to create this cluster code. It's going to take a hot minute to set up, especially in community. community, it's a community edition, so there's a bunch of people in it. So in Bamboo Lib gives like an API to help all of this code here was created just from me moving the data around in the API. This is the only code I actually typed in here, was this test train split. And then the AutoML that I just showed through that screen, you can actually call it in a notebook. So I decided to get pretty lazy on doing AutoML, and I just put this code in, and this is what it creates. So like, I can just use this. It did a data exploration notebook. It did a best trial notebook. And then you can see information about all the trials and the experiments. And that was literally me just hitting return on this. So I did data prep with Bamboo Lib, which I can show. I don't know that my cluster will have time for that because I see something is in the chat. But the data exploration notebook is automatically created. It does pandas profiling, so that's going to come up. It created this logistic regression notebook, which is still loading. Here we go. Again, this was not anything I had to hand code. This was automatically generated through the AutoML. So if I want to change the training size, if I want to make any adjustments, this is mine. I can, edit it to my heart's desire. And then it also automatically tracked an experiment, so I can see all of the experiments that contributed to this. And let me look at chat. Oh, okay, thank you, Mimi. Appreciate you sharing. So yeah. The Bamboo Lib, that's definitely going to be something keep an eye out for. I think it's definitely worth its own session. I think I attached that, yeah. So I'm gonna let that run. I'm gonna go back to my original notebook, just kind of begin at the end. And this notebook shared, you should be able to basically reproduce all of this unless you're using community. There's a little bit of a difference with that model registry. But I wanted to make sure I gave you all something that you could walk through, kind of understand how this makes the ML flow process or the ML ops process a lot easier, if that's been a challenge that we've all had. And then, yeah, let's see if I have anything. Nope, that's it for the demonstration. That's it for my presentation. Yeah, I'll keep on chat. It looks like we got good 4 more minutes in case any more questions come in. I do hope this was useful, helpful. Hope you learned something. At the very least, look up Pandas UDFs. I mean, that has been a fun little game changer. I wish I had that. It would have saved me a lot of time when I was doing my capstone project. So yeah, thanks everybody for coming. I'm going to stop my share. Unless that's running. Okay. That's it, folks. I'm happy to do any Q&A, or is anything come up that I need to speak to? If I believe we're going to give you all a chance to give feedback on the sessions. Any feedback's good feedback. It's how we get better. So yeah, let us know if this was useful. Let us know if there's other topics that you want to see or other topics you want to focus and hone in on. We're happy to do that as part of the solutions architect team here at Databricks. This is a quiet group. Usually the Q&A is lit. All right. If that's everything, guys, thanks for coming.